In an era where the fight against climate change is becoming ever more urgent, scientists are turning to an unlikely but invaluable ally: animals. Our planet's diverse fauna navigate, interact, and adapt to Earth's environments in ways humans cannot easily replicate or sometimes even detect. By tapping into the unique perspectives and behaviors of these creatures, researchers hope to unlock new insights into Earth's changing climate. But how exactly can the movements of animals offer us a deeper understanding of our planet? The quest to comprehend the vast, intricate mechanisms of our planet has long driven humanity to develop increasingly sophisticated technologies. Among these, satellites have been instrumental, circling the globe to gather data on everything from temperature fluctuations and CO2 emissions to natural disasters. Yet, despite the wealth of information these orbiting observers provide, there remain significant gaps in our understanding, particularly in how rapidly our climate is changing. Enter a groundbreaking approach, harnessing the power of animal movements through advanced tracking technologies to gain a more nuanced view of our environment. This novel perspective is championed in the research titled Animal-Borne Sensors as a Biologically Informed Lens on a Changing Climate, spearheaded by Diego Ellis Soto, a graduate student at Yale University and a NASA Finest Fellow. The inception of tracking animal movement for scientific insight is not new. It dates back to the early 19th century when American naturalist John Audubon used a simple piece of string to study bird migration. Fast forward to the present day, and the methodologies have evolved from strings to sophisticated GPS tracking and remote sensing technologies, enabling scientists like Ellis Soto to study animal movements with unprecedented detail and scale. The essence of this research lies in its ability to complement traditional climate monitoring tools, which, while powerful, are not without their limitations. Ground-based stations, constrained by their fixed locations, and satellites, hindered by cloud cover and the cloak of night, provide incomplete pictures of the globe's environmental health. Animals equipped with sensors, on the other hand, can fill these gaps, offering continuous, real-time data from the most remote corners of the Earth. These animal-borne sensors, ABS, have already shown their worth in various studies, from tracking the migratory patterns of birds to monitoring temperature changes using elephants in South Africa's Kruger National Park. Ellis Soto and his team see animals as biased sensors, a characteristic that, rather than being a limitation, is actually a boon for scientific research. This bias, dictated by an animal's ecological behavior and habitat preferences, allows researchers to target specific environmental phenomena with a precision unattainable through other means. For instance, ABS data has provided detailed insights into snowmelt patterns critical for agricultural planning and water resource management, showcasing the technology's potential to contribute significantly to our understanding of climate change's impacts. Moreover, the use of ABS extends beyond just filling in data gaps. It opens up entirely new avenues for environmental monitoring. The technology's ability to capture granular, location-specific data, such as tracking the progression of snowmelt across migratory routes in the Arctic, presents a more dynamic understanding of how climate change is reshaping ecosystems. The deployment of animal-borne sensors represents a convergence of technology, ecology, and climate science, offering a fresh perspective on the environmental challenges we face. While the potential of ABS is vast, the research underscores a collaborative vision for the future where the integration of animal movement data with satellite observations could revolutionize our approach to climate monitoring and forecasting. As we continue to seek solutions to the pressing issue of climate change, the role of our planet's fauna as unwitting yet invaluable contributors to scientific research becomes increasingly apparent. Through the careful application of ABS technology, we have the opportunity to not only fill the gaps left by traditional monitoring methods, but to weave a richer, more detailed tapestry of our planet's environmental health. The collaboration between technology and the natural instincts of animals offers a promising horizon for climate science, inviting us to reconsider the ways in which we understand and interact with the world around us.